everyone, my name is Mridmai. I work in autonomous vehicle industry and today I'm excited to walk you through my project on sensor log analysis using graphs. I participated in this hackathon because I wanted to explore graph retrieval using Gen AI and how it can solve and apply it to various problems. Sensor failure in AV can lead to critical failures and hence it need to be addressed at the right time. We need to understand the order of the failure and the root cause of it. Thus, I built an intelligent agentic application that can detect, analyze, and visualize sensor failures using natural language queries, AQL, and cuGraph. I use nuScene open dataset. It consists of CAN bus signal logs from autonomous vehicles. These logs include information like vehicle speed, battery level, throttle, brake, steering angle, wheel speed, etc. The goal is to detect the failures and understand the order in which they fail and the root cause of the failure. So these are all the file contained in the CAN bus log. So it consists of front left wheel speed, front right wheel speed, rear left wheel speed, rear right wheel speed, left solar longitudinal acceleration. Then we have steering angle with the timestamp and its value. Then we have brake sensor, steering sensor, throttle sensor with its timestamp. For example, a faulty steering sensor might cause incorrect yaw rate calculation leading to stability issues. Similarly, a brake throttle conflict can indicate a system error that could lead to a crash. First, we created a pandas frame from a dataset where all columns include sensor values for a particular timestamp as row. So this is the timestamp column and these are all the sensors. Then I created a function to detect the sensor failures, adding the threshold values to all the sensors to detect the failure. To analyze the sensor failures, I converted the dataset into a graph structure. Each sensor is represented as node and the dependency between the sensor, for example, steering affecting the yaw rate, are modeled as edges. Here I have defined all the sensor dependencies and then I'm connecting the edges with the timestamp. To process this data, I use ArangoDB. The process involved creating two collections, sensors as node and sensor connection as edges, ingesting the real-time failure data from the sensor logs and storing the latest failure timestamp for each sensor. So I'm storing the status whether it has failed or not depending upon the sensor dependencies and the threshold values we have set, and it also stores the timestamp. For example, wheel speed sensor connected to vehicle speed and the brake sensor connected to throttle. This helps us to analyze how failures propagate through the system. Now that we have structured our data as graph, let's visualize it using NetworkX. We plot the sensor network, highlighting the failure sensors in red and operational sensors in green. From this graph, we can instantly see which sensors are failing and analyze how failures propagate through dependencies. For example, a failing throttle sensor might impact both acceleration and speed. To make this system more interactive, I built an agentic application that allows user to query sensor data in plain English. This is achieved by Gemini and Groq LLM, ArangoGraph QA chain to generate AQL queries dynamically, cuGraph and NetworkX to analyze the graph relationship. So here we are using text to AQL and then AQL back to text using Groq LLM. Similarly, we are doing text to NX algorithmic queries and back to the text. And then we are also analyzing the graph using cuGraph. Then we are deciding what is the best answer out of all the three results, which include the cuGraph result, the NetworkX result, and the AQL results. Finally, we are querying the graph. We are asking multiple queries such as which sensors currently have status failing with the timestamp, and here is the answer generated by text to network X. It is showing the failing sensors with their timestamp. Then we have AQL results, again the sensor and the timestamp. Now here the LLM is selecting the best answer out of the three answers from the AQL network X and cuGraph analysis. Here it is showing the following failing sensors were found listed in chronological order with their last update time: the front left vehicle wheel speed and its timestamp, which is connected to uh, front right wheel speed and rear left wheel speed. So it is also showing the failing sensors and its dependent sensors with the timestamp. The next query is find all the failing sensors with dependency and timestamp. So here it is again giving the uh, results generated by the network X. Then here it is result generated by the AQL, and then again it is selecting the best answer out of AQL and network X and including it in the final LLM output answer. Moving on to the queries in which we are using the cuGraph. So, finding out the most connected sensors with the timestamp data. Here, AQL gives us some result. Then, uh, there's some error in the network X generated query, but it selects the best answer as the cuGraph result. The most connected sensor is vehicle speed. Another query is find the shortest path from front left vehicle speed to battery level. So here there's some execution error for the network X query, but there are results given out by AQL, and it is finding the shortest path between front left wheel speed and the battery level is through the vehicle speed. I have created a UI using Streamlit where user can upload a sensor log file and then can query on the graph generated by this log file, such as find the shortest path from the front left wheel speed to battery level, or which sensor has the highest failure rate, and then it gives out the output. To summarize, this project integrates graph analytics and AI to provide real time insights into the sensor failures by combining ArangoDB, cuGraph, and LLMs. We can detect the failing sensor, analyze the dependencies, answer natural language queries dynamically, visualize sensor networks to prevent failures. This project showcased the power of AI plus graph analytics for the real world applications in autonomous vehicle systems. Thank you.